Right, what do we got here? Chat is on. Russell, hello Pat from Dubbo. Mark from New Zealand. Hi Clint. Rod, Rod. Welcome back. How's my volume, everyone? Can you hear me okay? We might need a bit more light on the subject in here. All right, here we go. That's better. A bit of light. Right, can just in the chat box, can someone reply? All good, excellent. Thanks, Russ. From the UK. Well done. Have volume, good. How you going, Rod? I hope you're better than last time I talked to you. Hopefully you're at home or back at work. All right. So tonight we've got a fairly quick one. G'day, Craig. Nick from the UK. What time is it in the UK, Nick? Must be either very early or very late. Mike, I don't know who that is. So today we've got a fairly quick one. We're going to be just talking about the PicoScope measurements and using rulers on the oscilloscope. 9 a.m. Oh, fantastic. 9 o'clock. Well, that's early. Our day's just about over here. Once this is over, I'm off to bed, I reckon. So we're going to go over the PicoScope measurements and in particular the rulers. A lot of people misuse rulers or they tend not to notice them or they don't use them to their full potential. And we're not talking about maths channels or doing anything silly. We're just talking about using the rulers as you would in an everyday situation, as to why you want to use them and when you would actually use them. I tend to use them for a few different tests. I don't use them for everything, but when I do, they are very, very handy for taking measurements. So we're going to have a quick look at those now. So what are rulers and why do I need them? So rulers are a way to simplify waveform measurements. And they could be time, voltage, amperage, frequency, or phase-based rulers. And we're going to have a look at each one of those in turn. Okay, so first one we're going to have a look at are the time rulers. So time rulers we can find on the bottom left of the screen. So what we'll do is I'll open Pico up in the background here just while I'm talking to you. There we go. And once, whoops, I've opened the wrong screen here. Paul from Hamilton. G'day, Paul. How are you? Let me get Pico 6 open on my other screen. Must be late in New Zealand. It must be about 9 o'clock at night over in New Zealand, is it? Yes, I would. Okay, so the vertical rules are the ones that run up the left-hand side of the screen. So they're the ones that measure our voltage, our pressure, or our amperage values. So the best place to grab those, if you can have a look at this picture here, we've actually got down the bottom left-hand corner of the screen, there's a couple of little boxes. So we can actually grab those things. Is it? Sorry, these are the time-based ones. What am I talking about? It's been a long week. So we've got these two little square boxes down the bottom left-hand side of the screen. And I might just quickly share my screen so you can see that. Here we go. Excellent. All right, so you can all see that scope running in the background. So that's just on demo, and that's an injector pattern. So at the moment, it's bugging me that moves all over the place. So I'm going to put a trigger there, lift my trigger up, and there we go. We hold that injector waveform in place. Now, the time rulers are very handy because what I might want to do is actually check and see how long this injector's open for. So down this bottom left-hand side, you can see I've grabbed this little box, and I can drag that across, and I put that at the very first part of the signal that I want to measure, or the control I want to measure. So we just drop that somewhere along there. Then I can come along and grab a second ruler. I've got two of these, drag it along, and just put it at the end of the the signal or the waveform. So what I've actually done, I've just placed a ruler on either side of my injector opening time. Now you can see down the bottom here, we're in milliseconds. Now we don't know exactly how far that's open, just looking off the bottom here. But you can see when I grabbed my first ruler and dragged it over, the measurement box popped open. Now the measurement box gives me a few different values in here. Now measurement 1 is ruler 1. And that's the first one. You can see as I drag measurement 1, it actually gives me, in milliseconds, the time from, where are we? 13, 18, 19, 20, minus 3. Geez, we haven't zeroed that very well. We're actually measuring from our 0 point, which is somewhere down the bottom here, up to our first ruler. And that time is measured at 1.1 milliseconds. Now that is from wherever this is 0. Now it's actually 0, somewhere along the bottom here, minus 3, minus 2, minus 1, somewhere in there. Our second ruler is taking a time base, again, from the first one, right? And you can see as I move the second one, there it is. Now it's actually measured in microseconds. What I'm really concerned about is when I'm looking at it, it's not so much these first two values. What I'm looking for is the delta measurement, and that's the measurement between the two rulers. And at the end of the day, that's what I want to know. I want to know how long this fuel injector is open for. Now, on this value here, on this demonstration we've got going at the moment, we can actually see our delta is around 1 millisecond, nearly 2 milliseconds, just based on that. Now we can get really flash, we can put we can zoom in, we can adjust that a little bit, fine tune our ruler to get it absolutely right. We can pause the pattern, we can move that ruler a little bit more to be 100% accurate. But really, what's a couple of microseconds among friends? And there you go, 1.1 milliseconds. As far as injectors go, this is all right looking at 1. It's a bit unrealistic. Most fuel injectors on cars we see are open around, at idle, around 4 milliseconds. And then when we bring the RPMs up, we actually see this time-based change. So what this is handy for is doing comparison between injectors. We might have an injector that's a little bit lazy. We might find all the drivers a bit lazy. We might find that we've got a cylinder running a little bit rich. What we might find is that we've got a good, a nice running car, and we've captured a waveform at some point in the past, and we're using that as a reference waveform because we know this vehicle runs well. And then we get a car that's come in and it's running rich or it's running lean, and we want to compare waveform sizes or injector pulse opening. The vertical rules are just quite handy to do that. Again, bottom left-hand corner, drag one over, drag a second one over. And the way I use it, I just always look at the delta. I want to see that on time. This is a fuel injector. We can see it for any other device. Let me just get our screen share, get my slideshow back up and running. Stop, start. Here we go. It's a bit of a pain to get around that. So what we're looking at is that first one, and it's, like I said, that was displayed from 0 to 1 milliseconds. As we drag the second one across, we get the second measurement, and as we drag, we compare the two, we end up with the delta measurement across them, and that's what we're looking for. That's our injector pulse width. That's the demonstration we looked at there. Like I said, we can use this for a multitude of different signals. All right, while we've got that same waveform up, what we can tend to use are our horizontal rulers. And the horizontal rulers are the voltage or the pressure rulers. And they're very, very good for checking our peak voltage or our peak back EMF voltage or our peak cylinder pressures when we actually take the measurements. Let me change this over. All right. And again, these can be found on the top left-hand side. Now, these rules, they're again a square box, but these are actually coloured in. So they'll be coloured in for the channel that you're measuring. Now, these ones are blue that we're going to be measuring. So I'll get back over here and show you my screen share again. There we go. Screen's up and running, so you can see where our two previous rules. Now, if we go to our top left-hand corner, just select that, and there's our little blue box. Now you can see I can drag my first line all the way down here to 0 volts. And that's probably a good point to start. There we go, 0, got it. Don't need to zoom that one in. And you can see I've got two rules. I've always got two rules because I want to measure my delta. Right, let's go to our peak voltage, somewhere at the top of the injector there. Now you can see there's rule 1 in our measurement box. That hasn't changed, but since we've added rule 2, we can see we've got a white square versus a blue square. Rule 1 sitting at 0 volts, rule 2 sitting at 2.81 volts, difference between the two, 2.81 volts. Now if I move my rule 1 back up to my injector line, here it is. That's actually going to give me my supply voltage to the fuel injector. So if we see that here, that's around 600 millivolts on this particular pattern. And the delta between our on voltage and our off voltage is now measured over here at 2.13 volts. Now that's a bit unrealistic for a real injector. As we know, gasoline injection should be around 12 to 14 volts on this first line. And our second line back here, again, it depends on the injectors used, but you're going to see upwards of 60 volts, maybe on average 80 volts. If you do this on a diesel injector, you're probably going to see around 110, 120 volts back EMF bridged up there. And again, I like to use those because I like to look and see how much back EMF is generated. Too much and we've got issues in our system. Not enough, we've probably got shorts in the injectors or the injector coil windings. So again, it might be something we want to use to compare injector waveforms. In this case, it's an injector waveform. I might want to use it to do some pressure comparisons. Right, let me get back to my slideshow. Start and continue. There we go. So this is what we've done. We've pulled these two rulers down. There's the first one. There's our second measurement come out. And we're looking at delta between those two. That's exactly what I've done on our screen share. Okay, the next one that we can use these for is when we're looking at pressure measurements. Now, we use these these horizontal rules, generally when we do compression testing. So I think a lot of you now have the pressure transducers or either the first look sensor or the in-cylinder pressure transducer. That's the WPS 500X or WPX 500S. I can never remember which way we call it. Much easier to say in-cylinder pressure transducer. Right, so what we tend to use rulers for in that regard is to measure our peaks. You know, we might want to run a line across the peaks, but we actually might want to just get a measurement because sometimes it's a lot easier to see a value up here to determine the actual pressure rather than looking on the side and taking a guess. So what we're going to do, oops, let me go back. I want to screen share automotive, pressure transducers, pressure transducer. Let me have a quick look here. In cylinder compression cranking. Let's have a look at this one. Yep, excellent. Screen share. Sorry, I like to talk to myself because it's only a webinar and I can't hear you guys. I tend to talk a lot. Makes me feel wanted. Righto, here we go, screen sharing. So what we've done here, we've dragged a rule, we've brought it back down. Now, the rule down here will do two things. One, it gives us a guide to look at our peak measurements. So we can see a lot more clearly whether any of these peaks are lower or higher than the others. That's the first thing we're going to look for. The other thing we tend to look for is if I'm going to drag this one all the way down to the bottom to the start of my compression, so that should be somewhere around 0. I can get as close to 0 as possible. Close enough. There we go. Right, we'll bring this one down. And again, I'm going to use the delta across the two to get my pressure measurement. That was definitely 2. That was definitely 2. There we go. So that'll give me a delta measurement across them. Now, I know because PicoScope's very good, we can come along here and, we can press it anywhere on this particular screen and get a value up there. But what it allows me to do is to get an average across all of them. If I've got some low and some high, I might be able to just sort of drag this down and get an average pressure. The rulers are actually pretty good. When we look down the bottom of our pressure transducer pattern, I'm just going to zoom in a little bit here. We're going to come down, we're going to have a look at this section. Whoops, this section. So for anyone that uses pressure transducers or in-cylinder compression testing, you'll notice after our compression tower, and we sort of pull back down here, the cylinder then goes into a vacuum measurement right down below here. And that means the pressure is lower than atmospheric. Both valves are closed. The piston's lost all its expansive energy, and the pressure's actually dropped way below 0. Now, we can tell what's going on in the cylinder as per how much vacuum's down inside here. And if you all know the old school way of putting a mechanical vacuum gauge in the manifold, and you used to be able to read that, you could tell whether your valves were leaking or not. This is doing exactly the same thing. But what it allows us to do is take a measurement as to what the vacuum actually is in the cylinder. So you can see, I might just close that up, bring them down again. There we go, let's get 1 down there. Let's get 2 down here. And if we have a quick look at our vacuum measurement, there we go, 184.4 millibars. And we can convert that back to the particular vehicle to see if it's right. Now, I work in inches of mercury, or Hg. So off the top of my head, I think, I can't remember what that is, but I'm looking for around 17 millimeters of mercury on a 4-cylinder petrol. But that's a good way to start looking for faults. Now, this is on one particular cylinder. I could do this on a lot of cylinders, and then I can actually check and see whether the intake valves are sealing or whether the exhaust valves are sealing properly, just based on that measurement. Right, let's get back to our slideshow. We're going to be on fire tonight. I normally run over. Stop. Start. I'm sure there's a quicker way to do this. Comparing pressure peaks in the compression test and comparing vacuum to troughs. We also tend to use these when we're measuring CAN signals. Now, I quite like using them in CAN because they tell me more than just the potential difference or the voltage differential across the two. And I'll just get a CAN low and high. Let me just get an image up here. Whoops, every time I open one, I'm getting the help screen. Right, here we go. Yeah, excuse me a minute. All right, so here we go, typical CAN signal. This looks like it's a reasonably accurate CAN signal. Oops, we've got a question here. Oh, David Smart, hello. How you going, man? Okay. So when we have a look at our CAN signals, we're sort of looking at this now. I could click up the top here, look at my voltage, click down there, look at my voltage and do the maths in my head. Now I know with any Bosch CAN system or GM, any system that is Bosch derivative, I should have a 1 volt differential across here. Now again, that's not too bad. I can see down here, I'm about 1.5 there and I'm about 3.5 there. Well, that's actually about 2 volts cross between the two. This one's dropped down 1, that's dropped up 1. Now, if I bring my vertical measurement down, there's number 1. Somewhere there, bring that down to number 2. Not quite on it there. There we go, 2.1 volts. So on this particular sample, we're looking at a differential voltage between our CAN high and our CAN low, both high speed, but this is CAN low, and we call it CAN low. If we have a quick look at it, because it's pulling from what was initially 2.5 volts, we can see on the right-hand side. It pulls from 2.5 volts down to 1.5 volts. If we look at our, I've only got one measurement there, 2.5 to 1.5, our delta is 1. So we call that CAN low because it pulls from 2.5 down. We call this signal CAN high or CAN H because it pulls from 2.5 or 3.5 volts up. Sorry, 2.5 volts up to 3.5. So that's our pulling up signal. Now we generally display these together so we can look at that differential voltage. And there it is. Now the reason I want to know what my differential voltage is because CAN signals are really, really particular on this differential voltage. At the end of the day, it doesn't matter too much whether there's resistance in the circuit or there's a failure, and both signals are sitting somewhere up here on the screen, but as long as that differential voltage is still accurate, right, that's what's going to get my message through. Obviously, we are going to still fix these. I have come across these where the CAN pattern has actually wandered all over the screen. It started down here, it's gone high, it's dropped low, been like a roller coaster. But the car was still running fine, it was still communicating fine because the differential voltage across CAN high and CAN low was still correct. So we tend to use these rulers just to check those signals back to OE specs. If they say there's supposed to be a 2 volt cross between the two, that's what we need. And if we have a quick look up at our delta, that's without even zooming in and getting that accurate. You know, we're pretty damn close to our 2 volts there. All right. Let's get back to our slides. Oh, here we go. We're back. Excellent. And then you can see we've taken our the differential voltage between CAN high and CAN low. All right. The vertical rotation rulers, these are actually really cool. I do like these. So rotation rulers we find on the bottom right-hand side of the screen. Now they're a little circle, and here it is down here. So I'm going to get a rotation rule up now. I might just get a pattern that will we can use. What's a good rotation ruler? All right, pressure transducers. Here we go. In cylinder running. Let's do that one. Excellent. So I've got that one up and running. I'll share my screen. So we call these ones are circles. We call these things handles. So where I've been talking about these squares, the coloured squares, they're called ruler handles because that's what we grab and what we drag. Let me screen share again. If anyone can tell, I'm a little bit tired. I've had third-year heavy vehicle apprentices all week. Been very exhausting. All right, so here we go. So what we're looking at here is a sample waveform of a pressure transducer. And this pressure transducer is inside an engine. And we've had the engine idling over when we've done it. So again, on our, you can see over here, we've got our first vertical rule. These are our time rules, right? So here's our horizontal rule. Now in this case, it's a pressure rule, right? So I can measure peak pressures. If I've got 2 channels running, I'll have a red handle on this side. Now, the case we're looking at now, we're going to use the little green ball or the green handle over here as a rotational rule. Now, you can see as I drag that one across, I don't know if your screens are really good, but I'm going to get down, I don't know, I'll get right over here and try and get somewhere in the middle of that compression peak. You can see that that is set at 360 degrees. And that's because it's a rotation rule. Anything we measure with rotation, we'll measure in crankshaft degrees. Now, the cool thing about this is, at the moment, I've got 2 of these, right? So I'm going to place one there and one there. So that's top dead center compression stroke. That's top dead center compression stroke. Now, this is where it gets really cool with these rotational rules. If I pop down here to our little lower toolbar where it says rulers, bring that drop-down box up. Now, here it is, the settings on my rotational ruler. Now, at the moment, it says I've got one partition, so I've got two rules, so I've got a delta between them. I'm just going to change that. 3, 4, 3, 4 rules. There we go. So I've now got 4 partitions, 4 separate areas. 1, 2, 3, 4. Just by changing that in there. Now I can change this to a percentage, and you can see here I've got some percentage values down there. I can change it to whatever I want. I could change that to, it's in degrees, but we'll say millimeters. I could do that. But what I really want, because I'm talking about crankshaft and rotation rulers, I'm going to keep it in degrees. Now, let me just get that up there. I can close that box off now that I've got all 4 of them. Now, here's the cool thing. I want to set this one at 0. I want to set this one at, say, 2 crankshaft revolutions. What's that? 720 degrees. 2 720 degrees. Click over there. Now, for anyone that's following me pretty close, you can see what we're on about here and what I'm doing. I've set this one so I can now measure crankshaft degrees for piston rotation. So top dead center on this cylinder is 0 degrees. Right, here it is there. We'll just clear that up a little bit. Now, for anyone that knows the 4 cycles in a 4-stroke engine, we have top dead center down to 180 degrees later, bottom dead center, right? Then we have top dead center again, bottom dead center, top dead center. And you can all see where I'm going with the strokes of this engine. In this area here, I've got my power expansion stroke. And you can see as the power pushes down the cylinder, we've got peak compression. The piston's now dropping down into vacuum. Let's bring this down to atmospheric. There you go. There's atmospheric level. Everything below this rule here is vacuum. Now, for those of you that know that what happens somewhere around bottom dead center, my exhaust valve opens. So that's probably right about there. My exhaust valve opens just before bottom dead center. So for those of you that know cam timing really well, now we know this is bottom dead center because that's 180 degrees from here. So we can see the exhaust valve is pretty much open here because now we're reading atmospheric pressure all the way across to this point. Bottom dead center, exhaust valve is open. Now we know over here we're back at top dead center. Now we also know somewhere before top dead center my intake valve opens on all engines. And we can actually see where the intake valve opens here with this little bit of noise on the pressure transducer. So we know shortly after the intake valve opens, the exhaust valve closes. Now, because our piston's traveling back down, our intake valve is drawing air into the cylinder. The cylinder pressure is now lower than atmospheric, and we can see the cylinder pressure drop down here, atmospheric pressure, cylinder pressure. We can now see back around here at bottom dead center, that's taken a full charge. The piston's now on its way back up. Somewhere around about this lump, the intake valve closes and cylinder pressure builds back up to top dead center again, where we started. So rotational rulers are really, really handy for when we're looking at compression waveforms and we're looking at valve timing. So anyone that's sat in one of my courses and we talked about pressure transducers, we tend to look at this and we do this test quite a bit because we can check camshaft position or cam chain stretch or cam belt stretch on an engine by doing an in-cylinder compression test. But we need to use these rotation rules to work out where the piston is. Then we just look at where this intake valve's opening. Now, we can measure exactly where that intake valve's opening by using our vertical rule. So I'm going to bring one over to here because that's where that bit of noise is. I'm going to bring my second one over here before top dead center. There we go. Now, if we come back up the top here, now you can see we've got this second line that's on our measurement box. Now, before when we brought our vertical rules over, we only had one line. You know, we had our position 1, position 2 in seconds, and then we had a delta. But you'll notice, because I've got my degree rules or my rotational rules over, this second box is opened up with position, right, and in degrees. So if we have a look, we can see my second one is spot on at 360 degrees. We can see my second one is at 341 degrees, right, which gives me a delta of 18.2 degrees. So again, for those of you that are into cam timing and know engines pretty well, this particular engine has a cam timing value. The intake valve is opening at 18.2 degrees before top dead center. Now, if I know the make and model of this car, and I've got the cam specs from OE, I can tell straight away, based on that little bit of noise, when that valve is actually open as to when it should be open. And that'll tell me whether my cam chain or cam belt's stretched by using these measurements. So this particular vehicle maybe it's supposed to have a intake valve opening at 25 degrees before top dead center. Well, if I have a look at any engine that has a stretched cam chain or stretched cam belt, everything will happen later in the cycle because it's delayed. And what that means is the valve will open later in the stroke, which means it'll open closer to top dead center, which means my valve opening point will be less than what it's supposed to. And in this case here, that's 18. If this is supposed to be 25 degrees, I can definitively tell you that the cam belt stretched or the cam chain stretched. And that's using the vertical rules and my rotational rules together. So that's probably a little bit more complex measurement, but it's a very, very good one to use. Again, this is really easy. You've got your pressure transducer in the cylinder, have the thing sitting there idling. I think I've only come across one engine where I can't see the noise, and I can't remember what it was now. It was a really good engine. It just wasn't making any noise on the intake. So it was a little bit harder to find. But on 99% of the other vehicles I've done, that little bit of noise shows up, and that is your valve opening point where it pops. Let me get back to our slide. Feel free to ask questions as we go, guys. I've got no worries about doing that. Stop slide, start slide, and here we go. Why hasn't that started? Oh, gee, that was a bit slow. Wow. Okay, so here's a rotation rule. So we've actually shown this image on an ignition waveform. All right, here's our compression one. This is what we looked at when I was sharing my screen. Rotation rules can be used when performing an in-cylinder running compression test. We use them to locate the engine strokes over the 4-stroke cycle, which we did. There we go. And again, this is how we select the 4 strokes. We select the petitions. We want 4 of them. Make sure it's in degrees. And we always find that down the bottom of our toolbar. Next. Drag the first ruler from the right-hand corner, which is what we did. We dragged it across. Drag the second ruler over to the end. And since we've got 4 petitions, it'll divide it up evenly. The one thing you must remember to do is click on the box down the bottom here and make sure you change the first one is at 0 and the last one is at 720. Again, must be 720 because we've got 2 crankshaft revolutions in a complete 4-stroke cycle. If you're doing this on a 2-stroke engine, leave it at 360. Okay, this is what we talked about here. We can now determine the actual camshaft timing by measuring the intake valve opening position and then working backwards, which we did. There's our rule. Oh, look at that. It's nearly identical to the one we saw. How cool is that? Again, drag 2 vertical rulers from the left-hand lower corner, align one with top dead center exhaust stroke at 360 and the second with the intake valve opening pressure pulse. The delta is the intake opening angle in degrees, and there it is right there. Compare it with engine specifications to determine if your valve time is correct. And I know a few of you have done this. I do it quite a bit to try and compare and check if I've got cam chain issues. and it works. It's really, really good. I tend to do it more on the Holden HF6s, those Holden or GM. I can't remember the prefix on it, LFA or something like that they call them, LFW engines, the ones that stretch the cam chains. And I tend to do it just to see, because we are allowed a little bit of margin there in stretch, so we don't actually have to replace the chain straight away. Although we do have to be careful, because some engines, if they've got 5 degrees difference, plus or minus 5 degrees, that could be catastrophic. That could equate to piston and valve interference, which is generally bad. Wow, we're on fire. Just over half an hour. I knew it'd be a quick one tonight. So they're the main measurements. They're the main rules that we're going to have, the rulers that we look at and that we use. We can add all sorts. We can look at frequencies. We can change them to quite a few different values. But at the end of the day, they're the most commonly used ones. But I just implore you, if you've got a scope, you've got it on a vehicle tomorrow, have a go, use them. What's the inlet valve timing figure on a Holden? I can't remember what it is on a Holden. I have to look it up. I've got the specs somewhere on here. But I know LFA is different to what did I say the other one was? LW, L something or other. I can't remember now. My brain's a bit fried. But what I can find, Craig, is I can look that up and I can send that to you. I'll grab that tonight before I log off here. Of course, I don't want to accidentally close the screen. Let me open that up. There we go. Let's get this one over here. I'll look that one up and I'll show you. Now, the other thing is, if you have a look, you'll see in the files, okay? So in the file sections down the left-hand side, how do you change the pressure reading to PSI? I can't remember, Paul. I've been asked that quite a few times, and I can't remember if I've actually done it or I'm stuck with KPA or bar. I think I'm stuck with the two measurements. We go into settings on the particular edit views measurements. It's in Pico settings, startup settings, user defaults, same default settings, measurements, tools, preferences. There we go. Regional printing colors, sampling, updates, options, reset preferences, sampling. Paul, I can't remember. It's getting very late in the day. I'll find that out. I think I've got your email address here. I'll find it out. I'll screen capture that before I walk away from the computer tonight, and I'll send it to you, because I like PSI rather than bar. PSI, KPA I can deal with, but bar or pascals, I struggle. Regional language, general. I'm sure it's somewhere in the general settings on the scope. Right, so that's two things that I'll do before I PSI and LFW intake settings, intake valve. All right, excellent. Where do you find the intake valve opening degree specs? Mark, it depends what engine you're working on. I get all my stuff, because I specialise in the Holden, I just get mine straight from the, I use AC Delco TDS, and I go to service information. I pull it straight from the manufacturer. There's a lot of aftermarket repair manuals out there that will give you valve opening specifications. I've used Climber manuals, Haynes manuals, quite a few different ones, but generally under engine specs, they'll have camshaft position or camshaft intake valve opening. They'll have the duration angles. Now, providing no one's changed that cam from original, and that's the only downside to this. Hopefully, if they've changed the camshaft, they can give you the cam card and go, this is what it should be, and then you can check it. So as I was saying, this presentation has been converted to a PDF, and it's sitting in the file section. So if you click on just to the left of the chat, and you'll see there's a files there, you'll see the PDF, and I'm sharing it now. So you can download that, use it as a reference. Again, it'll just be for the sections, the basic measurements you're going to be fine with, but probably that second part where we're actually looking at the camshaft opening, you'll be able to use it to reference that. Yeah, no worries, Russell. Generally, I rabbit on for about an hour, but this is just a nice short one tonight, just to keep it brief. So I hope you got a little bit out of it. All right, guys. So on that, I'll hang around. I'll look this up for you, Paul, and I'll email that because I've got your address there. I'll find out how we can change it. I have done it. You do owe me a beer or two, Pat, and I'm going to take you up on that. I'm absolutely going to take you up on that. All right, everyone. Please enjoy. I'll keep the chat box on. I'm just going to turn the camera and microphone off. So feel free to ask questions for the next 15, 20 minutes while I look up this information, and then I'll close off the room for the night. Yeah, excellent. No worries, Mark. I like them when they're quick too. I love quick one. I hate it when a trainer gets there and just talks and rabbits. No worries, Russell.